All right, so customer shared this model with me, and a few interesting things came up that I thought I'll share. This would be good for new users, maybe hopefully for advanced users as well. So first thing I'll do in this model is to just get rid of some of the detail that we don't need using the defeatured tool. And then I'd like to copy one of these plates to this position over here to also indicate another piece of functionality. But before I do that, I'm just going to hide or delete all these nuts and bolts that I don't need. You'll see my keyboard shortcuts at the bottom and any keys that I press as well as the mouse cursor. So I'm just selecting everything from the model tree using this filter. And I'm just deleting them from the model because I don't need them. Benya, will you also add new attendees, please? Okay, so with that out of the way, I'm going to create a copy of this component and place it on the front of that beam. And the quickest way to do that is to double click on this triad, select the from location, and then select the to location to be the center of this face over here. And I'm just waiting for that little dot to appear. And there we go. And let's create the mid surfaces quickly. What I'd just like to hide at this point is these solids that I won't be creating mid surfaces from immediately. Wait, I want to use the bearing so that I can use it to show how to create a revolute joint in Apex. But these solids I'm just going to hide for the moment. So I'll be using those guys. And I'm just going to create the mid surface. I always use the auto mid surface thickness tool, even though it's actually only developed for components that have uniform thicknesses. This is always my go-to tool, and only when something is wrong or didn't work out as well as it should, I'll move on to one of the other options. So for instance, in this case, we see that majority of mid surfaces were created quite nicely with the appropriate thickness assigned. The only exception being these beam sections over here, because of the large fillets, that modified or changed the outcome of the mid surface, unlike how we would want it. So I'm just going to quickly delete those erroneous little filleted mid surfaces, and then I'll quickly extend the web faces so that they are properly closing all the gaps. So I'm just quickly deleting these little fillets there, and I'm going to quickly close the gaps using this tool over here. I don't want to extend the faces at the moment to the adjacent beams because I'm going to use glue contact and show how that works. But for these individual beams, I'm just going to use this tool. So now the gaps are nicely closed. So I'm going to do the same there. And the same over here. Okay, that should be it. I see there's one face over here that didn't properly stitch, so I'll just manually manipulate it a bit. Okay, and that is this yellow guy over there. Okay, so now the rest of it are fine. I'll leave all these bodies physically unattached, but we're going to attach them using glue. We actually get better results that way in any case. So I'll be demonstrating that as well. And now we can mid-surface all of these bodies in one go. And now to quickly demonstrate how to place a point mass at an arbitrary location. So first of all, I've switched off the auto execute option so that I can select multiple locations like this. And the way to offset it, as you can see, by default, it puts it in the center of the selected bodies. And we simply switch to this mode. I should have started with that, sorry. So let's just do that again. So I'm selecting those edges, moving on to the next stage. Now it asks me to locate the pot. Now there's nothing to put in this area, so I'm just putting it at any stage, any location, and then using this button over here, I'll be picking the center of this face over here, which highlights. And then I'll just simply type in an offset value over here that I want. Okay, and that is how you create your, now I've done exactly what I shouldn't have done. I didn't commit fully, so let me just quickly repeat this. So definitely a good day for things going wrong. There's the dot. And unselect that, select this guy, type in the offset value, middle mouse click, and what I've missed previous time is the middle mouse click again to accept the default orientation of the body, and now I can exit. Okay, so now I have a 500 kilogram mass attached to those 5 holes over there. I could have also done it in a different way, but this is one of the easy ways to do that. Right, so just to check that all the thicknesses are correct, there are 2 ways of doing that, and it seems that not everybody is familiar with that approach. So now we can see the color range over here. We can also render it in 3D to ensure that the values are indeed correct. Or what you can do is switch over here from the model view to the section view. And then we have a list of all the different sections and their values. Whether they're constant or variable, they'll show up over here. And if there's anything that don't have a thickness assigned, they will show up over here as well. In this case, it would be the solids that do not have a thickness. So everything seems fine. And now it's just a matter of connecting all the bodies that we want connected. And you may have noticed that the previously called glue connection has been renamed to mesh independent ties. The reason for that is because glue is actually a kind of a material that they'll be using, or that they are actually using extensively in the Actran and Digimat environments. So to avoid confusion, they've now renamed it to mesh independent ties, which we all know as glue. And I will just start off by gluing everything together, which is not the right way, because it will actually show me a few problem areas, and that is what I'll be addressing now quickly. So first of all, I don't want these large patches of surfaces to be glued together, so I'll be deleting their glue definitions, because I only want them to be connected with line welds or with bolts. And I'll actually show you how to use or define a line of a weld as well. And one other problem that I remember seeing. Oh, okay. So I haven't created the solid mesh for the pin yet. That's why there is no glue, because I remember the last time that I've done that there was also what's the word? Oops, it glued incorrectly. So let me just show this guy quickly. So let's create the mesh. It's a bit fine. Oh, that's not great. No, let's rather keep it at 10. Okay, that's fine. And now to just show the other one that I can mesh this one as well. Okay, and let me show you in any case what happens if you just glue everything together. So if I just glue everything, again, what I've picked up is that it also generates a glue contact between the pin and the plate over here. And that will eliminate the rotation, which I don't want. So I'm just going in there and deleting that. I just have to set up this glue as well between those three bodies. Okay, and you can see all the elements are highlighted where the glue, or all the elements that will participate in the glue are highlighted. So this makes it quite convenient for all these bodies because they're not stitched, so we don't have any duplicate mass issues. And we just need to double check that everything is indeed welded where they should be. Okay, so these plate bodies I also don't want glued, so I'll just be deleting their definitions. And now I'll use a glue, but in a little bit more manual way, to show how to only select an edge of elements, which I haven't done correctly. Let's just repeat that. Switch to element selection mode. Okay, I'm only going to use those guys and that body. So now I have glue defined at the top elements to kind of represent a weld. And I'm going to quickly do the same over here. And there we go. Now, of course, you may want to split the plate to have nicely, evenly spaced elements so that they're not jagged like this. So one way of doing it is to utilize the solid that we actually have available and use the split tool over here with the offset option. And let's say we want a weld of 15 millimeters thick. I am going to split this surface with the face of this solid. All right, and I can do the same on this side. Split this guy with this face with that offset. Okay, so now I have a nice portion of a face that I can rather use instead of those elements, because the remeshing took place. The elements was unselected, but now I can select that face and that face, and I have a nice weld representation over there, and the same over there. And over here, I am just going to be a little bit lazy and only select the elements without needing to split the solid up, split the face again. So for that edge and this edge. So this is now a nice way to represent the fact that the plate will only be welded at the top where it connects to the beam at the back and welded over here. So let's assume it's not welded anywhere else. Okay, and then for these plates, we just need to connect them. And this we do using the connector option, and you have different options, whether you want to use a rigid or a flexible beam element. I'm just going to use the rigid for now, and it's merely a matter of selecting the two opposing edges that has to be connected. Okay, so that very quickly sets up those connectors. And in a matter of a few clicks, I have those bolts created. Now, if you have a very large model with hundreds of bolts, now this will also become, even though this is much quicker than how this was done in the past, this can become a tedious job as well. And there are a nice script available to actually generate hundreds of bolts in arbitrary orientations, etc. Right, so this should be it. So I think the only thing left to do is to create our material. I normally have this pre-set up, but this is a fresh installation and didn't yet generate the or assign the script that normally does this. Okay, so if you're now not sure whether or not this model is ready for analysis, I see there's an exclamation mark, so let's just find where the problem is. And it seems to be two glue patches that don't exist anymore because of the geometry that was removed, and I can just get rid of them. Now let's see if this model is ready for analysis. I'll place it in the analysis scene, and it says that there's missing constraints and missing loads. So that's an obvious mistake if you want to do a linear static analysis. So let's just quickly add a gravity load. What will obviously, oh, I forgot to generate the joints as well. So we need to add that. And let's add some constraints. I'll just use a fixed constraint, and we can actually maybe not fix the whole plate, but only the bolt holes. Or if it attaches to a very stiff component, we can just connect everything at once, although it's generally not necessarily the best idea because it could be over stiff. So I'll just rather use this option as if there's no backing support. Okay, so now everything should be fine. I'm going to run a modal analysis though first, just to check whether the joint connections are correct. And I've just realized I haven't created them. So let's quickly create joints. And for the purpose of this exercise, I'm simply, oh, there's a little feature that I've missed that I don't need in this little, suppose it's the hole for the grease. So I'm just removing that, and let's joint those bodies together. So it's a revolute joint, and I want it on this side attached to that end, and on this side I think I'll just use the face of this solid. What I could do, maybe it's a better idea, is to okay, I don't need those details of the bearing, so let me just get rid of them, and let's split this face so that I don't apply the joint to the complete face of the solid, but only to a portion where the bearing is. So I'll just use my split tool to split those two faces using those two edges. All right, so now I have a nice split. Let's do the same for these guys over here. Just want to delete the bodies that I don't need. Using my split tool, I'll be splitting those faces, referencing these two edges. So now I have a nice face where I can attach my joints to. All right, so for this, I'll be using these two faces for the first side of the joint, and then for the second side, I'll be using these two faces. And there's an icon of the joint, so you can check that the orientation is it as you want it. It automatically uses any cylindrical features that you've selected to orientate the joint. But if you don't want to orientate it in that way, but in a different way, you can modify that. So that's quite a convenient thing to do. And I'll just repeat it quickly for this side as well. And so I'll be using this side for the first side, and then for the solid, I'll be using those two faces. The reason there's two faces and not a single one is because of the CAD tool that was used that brought it in. So, all right, so now this model should be fine. And to check that everything was corrected conveniently or perfectly, let's put it in an analysis scene, but set up a modal analysis to check the modes. And this should run fairly quickly. We can actually check exactly how long the analysis takes afterwards by opening up the simulation status tab over here. If you open it up before running the simulation, it actually updates in front of you, but once the simulation is running, you just have to wait for it. The first time you run the analysis, it takes a little bit longer because it now generated computational parts for all the loose parts individually. So second time round, when you run the analysis in this particular model, it takes about half the time. So let's have a look at the results. So we should be having one rigid body mode for the part that rotates, and if it isn't, then we have made a mistake. Okay, so it always jumps to the first non-rigid body mode. So there we can see that mode. But the first mode over here is the rigid body mode. And now we can see that the joints were indeed applied correctly, and we shouldn't have any load transfer in that direction. But while we at it, we can jump to the different modes, maybe plot some arbitrary fringes, maybe use the strain energy option to just get some nice kind of stress plots. But the more important thing is to double check the movements of parts. So let's move on to a different mode that shows higher relative movements like this. And we can double check that all the parts are indeed connected as they should be. So now you'll notice that those gaps that I've left there absolutely doesn't give us any problems. This is a nice mode. So this mode actually shows us very nicely how the plates behave. So we can see those two plates separating from one another and all only being kept together, being used by the bolts. And these ones at the back are only connected at the edges, top and bottom, and not anywhere else, exactly like we intended. All right, and I see my time is up as well. So that was how to set up a complete model in less than 30 minutes, while even talking in between. And yeah, we've covered a number of things. We modified mid surfaces, we used glue, we used joints, and we also added a point mass right at the top there. So if you'd now like to do a static analysis, we can do that. We'll just have to put on the handbrake to eliminate that rigid body mode. So the real model has a lateral actuator or gas strut that locks it somewhere in this region in a lateral direction. So let's just put an arbitrary thing over there. So now the linear static analysis should be fine. So let's place this in the analysis scene. And it will reuse the computational parts from the previous analysis. I just need to switch to a static analysis. We can do the frequency response analysis or buckling analyses as well. And it's missing a load, which I thought I did create. Just add the gravity in the negative y direction. And that's it. So it is happy. And we're quickly running the simulation.
Paul, that's right. When you created that point mass, then you whether you connected via RBE2 or RBE3.
So the default for the point mass, if you define it like the way I've done it, it creates an RBE3. But if you want to use an RBE2, you just simply create the RBE2 in a similar manner. And I can quickly show that, how that can be done. But just to show, this is the stress results of the structure. And we can also see the effects of the welds in that area. So if you wanted to use an RBE2, so this is the RBE3, that's what you actually saw from the modal analysis. So if we quickly go back to the modal analysis, the results. One of the modes actually showed it, if I can just remember which one. That one. Yeah, this one actually showed that mode. So you can see that the RBE3 didn't add any stiffness to the plate, but the mass is clearly acting in or playing a part in this mode, as was shown in the static analysis as well. So if you want a very stiff connection over here, we need to use the RBE2, in which case you can use the discrete ties, which is the manual method of defining RBEs. So you can pick rigid, which is your 3-1, and now it's a matter of defining the first portion, and then for the reference point, we can again use this method where we pick a point there in the middle, and then you can type in a value again or just manually grab it and put it somewhere. And now you have a location where you can add a point mass to. So let's add another point mass. And this time I'll use this method. You can see there you have the option to select a tie location. So if I use that, I've applied my I'm doing the same thing again that I've done this morning. Middle mouse click to commit and commit again for the orientation. Okay, so there we go. So now there's a mass as well. Okay, so the default, as I said, if you don't use the RBEs and you just place the point mass using this remote location method, it's an RBE3. If you don't want an RBE3, you'll just do it the way I've done it now the second time by creating the RBE3. Obviously, you can reference the bolt holes as well. I just done it this way to clearly distinguish the two from one another. And then you place your component or your boundary condition or whatever on that location there. Are there any other questions?
Sorry, Paul. One more.
Yes.
When you glued the portion of elements to the plate behind it for the weld,
yeah.
Is it okay also to maybe just glue the edge nodes? The nodes on the edge to the plate behind it.
I didn't check if that is an option, to be honest. No, it's not an option. You can only select elements.
Thank you.
So it's like a face-to-face kind of contact.
Okay, thanks.
Sorry, Paul. It's Craig. Is it possible to see the loads or the stresses in the glue element, in the glue?
Yes, that's actually a new feature that's been brought in. I'm actually running the beta version. I'm very brave, even though it's a Friday and my week hasn't gone so well. But since this version, the official version was supposed to come out this week. I'm actually surprised that we didn't get the installer already. I didn't check this myself, but that was one of the things that featured in the release notes. So yeah, you see the connectors, the joints, and I am surprised. Why don't I see the glue? Because that was definitely one of the features that they did mention. So, Craig, that is where they've where that should have been made available. I don't know why this beta version of mine doesn't have that. Great. Then that concludes the session. Next week, Gerrit will be hosting a session on meshing. Not necessarily about Apex, but on meshing strategies and why you mesh something in a particular way, etc. All right. Thank you, everybody.